Professor Peter, welcome to the podcast.
Hi, thanks for having me.
It's a real joy. I have to admit, the reason I invited you is because I am terrible at mathematics, and you're a professor of mathematics, aren't you?
I am.
Yeah, and you also do math stuff on Twitch.
Yeah, in March when everything kind of shut down with COVID and everybody in my position was forced to be working from home, we kind of pivoted and found a neat little niche, I think, on Twitch. There's a couple other professors doing similar stuff, so I was able to kind of take a lot of lead from them. But yeah, so that's what I'm doing now.
Yeah, that's how I learned about you. Actually, I ended up. I think I discovered you through some other STEM streamers, and I watched one of your shows. You were demonstrating something with pigeons. Don't ask me to remember what it was, but it was these birds, and you were moving into different columns, and it was like hotel rooms or something. Do
I
you
remember
recall this
that. Yeah,
exercise? What is
we
that
were
exercise called?
we were talking about the pigeonhole principle, which
Right.
is a really kind of intuitive thing at first when you just explain what it is with like the metaphor of the pigeons and the pigeon boxes that you're putting them in. But then we ended up talking about Hilbert's Hotel, which is a weird way of thinking about infinity and stuff like that. Yeah, really cool stuff.
What I loved about that, Peter, is that I failed mathematics in high school. I had to restart it. I was a terrible, terrible math student. I would even probably guess that I probably was like a form of math dyslexic or something.
Hmm.
But what I found was that when I watched your Twitch stream, I understood. It was the first time in my life that actually clicked.
I gotta go find the VOD and download that and save it then.
Yeah.
Thank
Well,
you.
there's something to say about, visual analogies in mathematics.
Yeah,
So
yeah,
is that something you use?
that's something I've become a lot more excited about. I normally don't teach stuff like what you were watching. I normally teach, introductory calculus for first and second year college students, and so it's kind of their first experience with college level math, and it's this thing that I feel like everybody kind of looks at and knows about before they get there, right? It's this kind of Everest in the distance that we walk towards in math education. It feels like. Um, and for some reason, these classes have built up this kind of like mythos, I guess, of being, yeah, just really difficult. And I've started to find a lot more ways of including visuals into my classes just because I think like there's nothing better than a really good, tight visual demonstration or explanation of something where we don't have to spend 20 minutes going over the really wordy particulars, which I think is something that people get really hung up on in math.
Yeah, it's a little bit like for I think the general population, if you were to ask people if they enjoyed mathematics, they would say, "No, it was like going to the dentist."
Yeah, yeah, probably. Which is always a little like sad to hear, but I understand.
Yeah, absolutely, and so now, I wanna start with asking you, what was it about mathematics that really got you hooked?
I've been asked that before by students, and to be honest, I sometimes have a hard time answering because I don't really know. I feel like I've always enjoyed it to some degree. I had a really good high school math teacher that instilled a lot of curiosity in me. I think, especially when I was in like grade 11 and 12, near the end of high school, starting to take some of those classes. I feel like I was given a lot of space to kind of ask questions and I don't know, I guess learn really. And then I pretty much just kept that curiosity going. I had a lot of really good mentors along the way that let me know that math was something that was exciting to me. I didn't really know that for a while, and I had a professor in university that kind of pointed that out to me, which was really huge. So I feel like I didn't really know it on my own, to be honest. Other people kind of reminded me that, like, hey, this is something that you really enjoy, um, which I feel like is bizarre, but also was a really nice testament to those people's teaching ability and mentorship. I really value that, and I know not a lot of people have that. So that's something that I'm really fortunate to have.
Yeah, there's something to be said about good teachers, especially at the high school level, and especially, like you said, in grade 11, grade 12.
Hmm.
That's really when you're deciding what you're going to major in, what you're going to do with the rest of
Right?
your life.
Yeah.
What, in your opinion, what makes for a good high school math teacher?
Oh, that's a really good question. And I'll preface it by saying I don't teach high school math, and there's a good reason for it. I don't think I'm fully capable of doing what they do because, like you said, those ages are so like moldable and transient, and it's really difficult to connect with those kinds of kids as well without kind of overstepping some of those bounds, but also realizing that like they're still young kids. I mean, grade 11 and 12, I was 17, 18 years old. I had no idea what I wanted to do with my life. And so kind of balancing that ability to follow curiosity and to be personable is huge. But then there also are so many strict requirements in high school education, about what kind of content you need to be going and what kind of pacing you need to have in a course. I feel like it's got to be a lot more difficult than what I do, to be honest, just because of all the different kind of requirements and regulations. I think definitely for high school math, it's about finding those spots in the curriculum that's already set out where you can follow curiosity. And there might not be a lot of them. There might not be a lot of those cases because a lot of what I think of as the really cool math doesn't show up in high school. But the really good high school math teachers that I know are able to take things that I wouldn't have thought of being things that would connect with kids and their own curiosities and really find ways of turning that around for students. And that's a really good skill that I haven't figured out fully yet.
You keep bringing up the word curiosity, which is curious because to me, what I hated about mathematics was that it was a formula. It was like,
Yeah.
you need to follow this formula. And as a naturally curious person, as a very artistic person, I hated that. I hated that. I was like, well, why not? Why not do this instead?
Hmm.
And the teacher would always say, "Well, that's not the way." So why do you put the emphasis on curiosity?
I think exactly what you said. Like so much of math teaching, historically at least, has been about like a formulaic approach to things, especially when you think about what the high school math curriculum is mostly geared towards. It's a lot of algebra and trigonometry and a lot of pre-calculus stuff, moving towards calculus, right? Um, and we've kind of, as a field of educators, cut this up into some kind of basic formulas like what you said and basic results that we move through in the same process, and it's really become, or at least can become, really dry, and it looks like we've burnt all the curiosity out of there. I think the really good math instructors are able to focus on the why as opposed to the what. So instead of here's a formula, let's think about it and let's apply it, it's, where does this come from, how does this match with our intuition, why are we doing this thing? And those are the fun questions to start answering. And I know it's got to be really hard to do that in a curriculum that is so kind of almost machine like. You know what I mean? Like what you said, here's a formula, memorize it, use it. I think that's a really easy way of sapping the curiosity out of students. But if you can tap into this kind of like, why are we doing this and where did this come from? And even thinking a bit about the history behind things, I think those were the things that really kept me engaged as a student.
So at the college level, that's what the level that you teach at.
Hmm.
Do you have a lot of room to do that?
I feel like I do, partly because the subject that I teach has just a ton of that in it. Introductory calculus is full of concepts that maybe seem basic and intuitive, but have a really rich history behind it. Or even concepts that don't seem intuitive at all, and we get to kind of run face to face with that, which is always a fun activity to do. I love finding ways of challenging students' intuition, and really kind of breaking that down and kind of figuring out why did we think this was the way that it is and why is it not. I think those are the really fun things, and they happen a lot in the courses that I teach, especially first semester college calculus. We get introduced to so many big, interesting topics that come with a ton of concepts. That are, I think, really kind of foundational to the way that we can view the world later on, in some of our other courses. And so I know that it's applicable and we can kind of find interesting ways of applying that and interesting examples of it. So I think the subject that I teach is just full of those moments.
So, what is calculus?
Yeah, so at its core, there's really two parts. And everybody might have their own opinion on this, right? There's always kind of the two sentence elevator pitch type thing that you can try and break down a whole subject into, but um, it comes in two parts. It's like a study of change and the study of accumulation. The more that I've taught it, the more that I've latched on to this idea of like what we're really doing in calculus is cutting things up into small pieces and trying to focus on those individual pieces themselves because they become easier to work with. And the other half of calculus is taking all those small pieces and adding them all back up together and accumulating them, gathering them all together. So that's essentially what calculus is. Along the way, you get to deal with really cool things like uh, the nature of infinity, because one of the really fun things in calculus is that these really small pieces, we try and make them like infinitely small, which is this weird concept that we have to formalize a bit. Um, and there's a lot of fun things that come along with that. But that's essentially it. It's breaking something down into really, really small components and studying them individually. And then the second half is just accumulating them all back up again.
So, what exactly is infinity? And the reason I'm asking is because it seems to me that this is all abstract. Like it how do you
Mhm.
apply that to like real life? Like how do you explain why infinity or the knowledge about infinity is important?
Yeah, so probably the best application that I can think of right off the top of my head is another big theme in calculus. It's approximation. What we do a lot of with this breaking things into small pieces and stuff like that is we approximate something. Whether it's an area or whether it's a rate of change or whether it's something else. We cut this object that we're interested in into a bunch of small pieces and we approximate whatever we're interested in on each of the small pieces. And then we can maybe accumulate that back together and get an actual approximation of the size of something or whatever. And so when infinity comes into play, it's when we try and say, like, well, what happens if we keep getting a more fine and more granular view of what we're trying to approximate? And we keep getting a more accurate approximation by doing this. We break things into smaller pieces and we get a little bit more detail in each of those pieces, right? And so when infinity comes into play, it's like, well, what would happen if we had an infinitely good approximation of this thing that we're looking at? And some of the tools in calculus allow us to kind of follow that line of thinking and try and make some really good guesses and sometimes really clever ways of applying a formula to something by thinking of it as an infinitely good approximation.
So, is that really the foundation of statistics?
Yeah, so all of statistics really is based on this idea, right? When we think about statistics, one of the things that comes up a lot is like probability distributions and stuff like that, right? Like a bell curve is probably the thing that comes to mind. You think about a distribution of grades on an exam or heights of people that you're surveying or something like that, and they probably sit around some average and then kind of tail off on either side of that. And when we think about probability, what we're really doing is thinking about like how many times does this event occur out of this many tries? How many people are over 5'10" out of the total population of people? That's a hard thing for us to survey, but we can get a really, really good approximation and then find a probability by applying what we call an integral, which is this kind of infinitely good approximation of an accumulation of things. So that's exactly it. Yeah.
Fascinating. See, I didn't even know that. So, it's another reason why I wanted you on the show is to explain to me things that I've always wondered about when it comes to mathematics.
Hmm.
The course that you teach, these are intro level courses for calculus, correct?
Yes, yeah. So I'm seeing students in their first and second year mostly, and a lot of them are taking, the first semester of calculus in their first semester of their first year, and then I'll see them in the second semester, and they'll move on from there. But yeah, it's a lot of introductory calculus stuff.
And are these prerequisites for their program?
Most of them are engineering majors or computer science majors, or I get some like biology, chemistry stuff. Every now and then I'll catch some pre med students and things like that. But yeah, I really don't see a lot of math majors in these courses. Every now and then I'll have one or two in there, but mostly it's some form of engineering.
Okay, yeah. So that is one of the questions is how how do you make how do you create enthusiasm or how do you find the
Right.
enthusiasm in a student who's doing this as a prerequisite?
I think for me at least the first thing is I just try and acknowledge that like they don't necessarily want to be here, and I have to convince them that this is worth their time maybe. I don't know if that's the right way of saying it, but right, coming face to face with the idea that like they don't like this subject the way that I did as a student or the way that I do now. um, that gives me a lot of motivation to try and find those things that are really cool, and try and find those things where I can kind of like pique somebody's curiosity and get them to ask a question like, but wait a second, like why is this happening here? Those are the fun things where I feel like I'm kind of turning them to my side. You know what I mean?
Mhm.
Um, and I tell this to my students all the time. I used to, when I was brand new, have a goal of like, I want to make my class like their favorite class. So throughout the semester, I'll try and convince them that this is really important and really worth their time, and it'll be their favorite class that they go to. And I've realized that that's just not a very good goal. I try and make it a safe and fun and laid back environment for them, so that they at least enjoy being in the presence of the people around them. And they might not love the content, but hopefully a couple times in the semester they'll find some appreciation for it. They'll be able to say, "Yeah, I didn't love it, but when we were talking about, this, that example was really cool. That was a neat way of thinking about things." If I can get a couple of those every semester, I feel like I've done my job pretty well.
Absolutely. And also, I keep asking you about students, having difficulty or hating math.
Mhm.
But what about the students who are genuinely good at it and in fact might even be gifted? How do you approach that? Like how do you balance instruction for, a class of I don't know how many
Right.
students you have, but let's say 30, 40 people, and then
Mhm.
you have that one or two people who are actually very, very gifted at mathematics.
So I'm lucky in that sense, in that I don't have big classes. The institution that I'm at, we've got relatively small class sizes. I've not taught the groups of 200 people in a lecture hall type thing. That's not my setup. So I'm in small groups of 25 to 30 students at a time. And so I feel like I do have a decent amount of time to get to know like who each of those students are and where they're at with their interest level. Um, and I found it's pretty easy actually to find kind of spots, I guess, to give some students that might be interested in more a bit of an opportunity to look at it. Um, in face to face classes before all this COVID stuff happens and I'm teaching online fully. I just would have a lot of time in my classes where I'm not physically lecturing. Students are working on things in groups, and I'm popping around to each group, checking up on how they're doing, and kind of maybe bringing a couple groups together that have some of the same questions. So probably half of my class time is spent that way, and that gives me a lot of opportunities to just kind of poke into somebody else's work and say like, hey, I know that you're probably doing okay on this, but think about this as well. And maybe give them a bit of a tease for some topics that are coming up or things like that. That's been pretty good. With the online format, that's something that I'm having a harder time with, and I'm having to try and be a bit more creative, I think, about how I do that, because I just don't get to kind of pop over and chat with each student individually as much. So I've been trying to find journal articles and things like that that relate to things that we're doing in class, but maybe like a lot of them are like, hey, here's a result that we learned in calculus, and this is only relevant if we have this really nice setup. What happens when we don't have this perfectly nice setup? What could we do then? It's not really in the scope of our course, but it's related. So I'll try and kind of tease that out with some journal articles or discussions when I can find them. The Twitch stream has been really helpful for that, because I have some time then to just follow little tangents and get off topic a little bit. But it's a lot more difficult, I've found, online.
Yeah, how are they learning online? Like, how does the online format work? Because I'm completely disconnected with that. I'm
Sure.
not in academia, so I don't know how teachers are using the online format. Is it like a big Zoom call and you see everybody, or is it like a
Some people are
one-on-one?
doing that. Yeah, and this is something where you say you're feeling disconnected from it. I feel like that too. Normally, I've got a bunch of colleagues, down the hall in my office, all that kind of stuff, and we bounce ideas off of each other. And I haven't seen any of my direct coworkers face to face in like several months now. And so it is a little bit weird because I don't really know what everybody's doing. I know some people are doing big Zoom calls. I am going with the asynchronous model, which is basically like on demand. I have a bunch of lectures that are recorded. I put them up on YouTube, and I have some notes that go along with those and kind of guided readings in the textbook, some summaries of topics. I have links to other people's content as well because there's tons of people doing math on YouTube. Um, and I have them kind of follow a general schedule of like, these are the topics that you'll need to know ish around this point of the week, or by, the end of next week, you should have gotten through this. But they are pretty much doing it on their own pace. And then I'm holding office hours on Twitch several times a week, trying to answer whatever other questions. I also have a Discord server up for my classes. And so I'm popping into there. Every now and then I'll do like a voice or video call with one or two students at a time there. So it's really kind of all over the place for me, I feel like. And I'm still trying to fine tune exactly how I want to do this because it kind of caught us all unprepared in March. And so I'm trying a couple things now in this fall semester. But I'd like to keep tinkering with how I structure my courses because it's all pretty new to me.
Yeah, it sounds like you're doing the best you can with all the available technology. Technology is fantastic right now in
Hmm.
terms of opportunities. Um, do you think the kids are gonna be okay?
I do. Yeah. There's certainly stuff that they're going to miss, right? I noticed that even in my classes this semester, that the students that are coming from the previous course in the spring, they might not know certain topics that well. But to be honest, that happens anyways. If a student takes a course one semester and then waits a year to take the next one, they might not be retaining everything. It's kind of expected and baked into how we teach. So I think it's going to be fine. And honestly, most of the students that I've had are really great at putting a ton of time and effort into this. I mean, it's a big challenging task that we're giving them to kind of learn independently, but with some guidance. And they are doing a great job. At least the ones that I'm seeing, they're doing a really great job of picking things up, trying to be engaged, even when there's not a physical room that we're all sitting in. And so I really honestly think it's going to be fine.
How long have you been teaching, Peter?
That's a good question. Let me start counting. I think this is my eighth or ninth year.
Okay. So
Yeah.
you've really had a lot of experience in teaching. So is there really such a thing as like a mathematic form of dyslexia? I'm just really curious.
Yeah, actually, when you said that, meant to remind myself to pull up a window and Google the name of it. I don't remember what it's called. It's something, I want to say it's something with like number as the base word, but yeah, there certainly is. And then along with that, there's a whole host of other kind of like um, mathematical challenges that people have. Right? There is math anxiety. That's a thing. That's a real, honest to goodness thing specific to our field. And there's kind of like trauma in people's backgrounds with math education, unfortunately. So there's a lot to navigate when we start diving down that rabbit hole.
Isn't that amazing? You don't get people who have music anxiety. They might have stage fright,
Right.
but this is such a unique field of study that makes
Mhm.
people sweat.
Mhm.
How do you approach a student with anxiety?
I've started trying to completely redesign my courses, honestly. I realized that uh, a course with high stakes exams, where you have to demonstrate some method in a specific way, like what you were mentioning earlier at the beginning of all this stuff, like those are situations that no matter what the field of study is, are going to cause anxiety. And it just so happens that we use those things a lot in math education. So I'm trying to move away from using, only a couple of big exams and uh, using things where I give somebody a problem and expect them to follow this very specific roadmap to an answer, and instead, uh, just really trying to focus on how can I tell if a student is learning something, and that should be how I grade things. That should be how I set the course up. If I can come up with ways of figuring out how a student might know something, that's my job in assessing them. It's not putting them in this tight time environment where they're sitting alone and working on this stuff with proctoring software watching their every move, which seems to be kind of the way that things are happening online now. That seemed to be really counterproductive to what we want to actually do in a course, which is measure how they know some sort of topic or concept, right?
What would you say to the critics of the critics who say that, changing this makes our students more soft, or it doesn't make them grasp the material? What would you how would you counter that?
People have been saying that for ages, though. In the I think it was in the late '80s. There was the calculus reform, which was we're going to move away from the kind of like drill mathematics where it's just do a bunch of problems and just learn it from that, and move towards more like applied and even using some computer technology stuff. And people complained that we were losing the rigor in mathematics. And the more people argue about this, the more I'm realizing that like I honestly just don't know what people mean fully when they talk about rigor. That's a really big buzzword in math. Our proofs need to be rigorous and our teaching needs to be rigorous. And I honestly think that for the most part, it seems to be a code word for it needs to be done the way that I know how to do it or the way that I've done it historically. I don't think that there's any measured differences between student understanding. And any of the actual measured differences in student understanding that have come from changing teaching methods have been only in the positive direction that I've seen. The more we loosen up those kind of like really strict guidelines, and the more we allow students to maybe, not have to work in these super stressful environments, the more receptive they are to course concepts. So that's been something I've been learning a ton about lately, and trying to implement.
Yeah, I think it really comes down to students being able to finally understand the concepts, because even back then, even with full rigor and
Hmm.
traditions, you didn't necessarily understand what was being taught. Like,
No, and some people
you know,
do, people don't. But I think the thing that people fall back on is like students can come out of that environment understanding concepts, but that's not a proof that that works. You know what I mean? Like that's I had some of that in my background, right? I'm a part of that group that did go through some courses that were set up to be this like really strict, rigorous thing, and of course, I made it through, and I love math, but I don't think that was the reason. And so why not find a teaching method that is going to give students a reason to really enjoy the concepts? You know what I mean?
yep, 100%. Uh, why did you decide to teach? Why not go work in a scientific field, or why not go do your PhD in mathematics and become a math whiz or whatever? Why did you
Right.
decide to teach?
Um, that's a really good question. I actually didn't know I was going to teach. I went to graduate school thinking that that's what I was going to do. I started off in college as a not as a math major. I started as a business economics major, until a professor kind of pulled me out and said like, "Oh, this isn't for you. You gotta find something that you like." And so even when I was going to graduate school for math, I thought I'm going to end up in this kind of industry side of things. And I think my now wife, she says that she always knew I was going to teach. But when I was in graduate school, part of my assistantship was teaching a course every semester. It helped pay for my tuition and stuff like that. And so I taught a college algebra class, and I just loved it. I loved being in the same room as 18, 19-year olds that are a little bit nervous about math, and I liked trying to make it cool for them, or at least make it even a little bit interesting. I liked all of the stuff that came along with the teaching part of it. And even then, I thought, yeah, this is really fun to do for now. But when I finish up this degree, I'm going to go off into industry. And then I just found like, that's not even remotely what I wanted to do. I just had so much fun in the classroom. It kind of caught me off guard. So that's where I ended up. It really changed a lot of my career plans late in the game, but I think it was for the best.
It sounds to me like teaching has really become more than a job. It's really a vocation for you, isn't
Oh
it?
yeah, yeah. It's something I love doing. I have I talk about this a lot with other like educators and stuff like that. I think a lot of people in the teaching field, we do it because we love doing it. There's no other way of saying it. And unfortunately, that means that like it's easy to get abused a little bit. You know, Teachers love doing what they're doing, and so they're continually asked to do more with less, because we love doing it. And that's something that kind of keeps coming up again and again and again. But overall, yeah, I think it really is something that most of the people that I know that do this. We do it because we're really passionate about the content that we teach, and we're passionate about imparting that to other people.
Now let's talk about Twitch
Oh,
because
sure.
you not only use it for I mean, you use it for your students,
Hmm.
but you use it for the general public, which I find absolutely amazing.
Yeah. So I've gone like up and down with how I use it just based on the time that I have. So in the spring semester when we were forced to go online, I really didn't think that it would be something that anyone else would look at. I thought this will just be a nice way of getting my students to view this. And I honestly thought I'm glad to do this instead of Zoom because then they don't have to show their videos. I didn't want to put students in a position where they had to have a webcam or have it on or things like that. So I thought this is a nice, easy platform. They can stay anonymous with usernames and all that stuff, which I really valued. And then it's actually funny. The first week of me doing it, I had people in the chat that weren't my students, and they were just kind of like trolling, causing problems. And it was so unexpected for me that I didn't know how to do any of the moderation stuff. I had no clue. So I just was like, sorry, guys, like for all my students. This is just going to keep going until I finish, and then I'll have to go learn how to actually like keep control of this. But then from there, yeah, more people just started swinging by, and so eventually I was doing like fun math nights on Wednesday nights, and just talking about kind of interesting topics, things that I thought were fun. That's where you probably saw the pigeonhole thing. And then once I got back into like my really full semester, I've scaled back on those, but I'd like to keep doing those again, put them back in place instead of just doing kind of office hour streams for students. Even in the office hour stuff, though, that I have a pretty good sized group of non students that hang out and ask interesting questions, and we just kind of chat about math topics, and it's a ton of fun.
Yeah, I think it's first of all, most people don't know that Twitch is, has streams that are not just video games.
Right, right,
So already you're kind of, breaking through perception about
right.
Twitch. It's something that I'm used to as well with my Tiny World account, which is
Hmm.
that people come and see tardigrades and they're like, I don't know
What
how I
game
came
is
across
this?
this. Yeah,
Right.
exactly. Yeah, they're not really sure what they're looking at, but they
Mhm.
stay because there's a fascination. And do
Oh,
you
yeah.
find that that's what the people who are not your students, what do you think it is that attracts them to your show?
So some of them just come to ask their questions for stuff that they're learning. There's I can't even think, probably 5 or 6 people that I can think of off the top of my head that are just self-studying math. Some of them are long out of college and high school, and they just wanted to go back and learn some of the things that they'd heard about, or they were in a spot where they had done really poorly in their math classes, and they're later on in life they want to go back and figure some of this stuff out. Some of them are students, just not mine, and so they hang out and ask questions about the stuff that they're learning, which is super cool. um, but I think there's a lot of people on Twitch that have a decent science and math background, and that surprised me. I get a lot of people that are really smart hanging out in my chat, and some of them just hang out to help students, which is really cool. And some of them just hang out to kind of like I think for them it feels kind of comfy. There's somebody on the screen talking about undergraduate college math, and that's something that kind of feels like home to them, I guess, in some weird way. But it's super cool. There's just tons of different people. I have a couple of people that are like high school students, and so they don't really understand all the stuff that we're talking about. They just like to watch and kind of see what's coming up around the bend for them. And they'll ask their questions about some of the concepts that we're talking about, and that's pretty cool.
Do you use Twitch for other things or just for math?
I only use it for math. I knew that it existed as a video gaming platform, but uh, honestly, I only know it as a platform to host educational streamers. That's pretty much all I watch on Twitch. That's all I really know. So there is this whole other side that it's like a reverse experience for people, like what you said. People stumble into your stream and they're like, this is a brand new side of Twitch. I have no idea that this existed. That's what I feel whenever I come across a video game stream. It's like this is a brand new side of Twitch when really that's what the platform was built for. But I only know the educational side of it.
Okay, yeah, and I can totally relate to what you're saying because I had somebody who was doing his PhD in applied math the
Mhm.
other day, and I was like, "Wow, somebody who's like, very, very knowledgeable in mathematics is watching me." And I honestly, I dropped out of university, so technically, on paper, I only have a high school education.
Mhm.
So it's always amazing to me. There's a little bit of imposter syndrome,
Oh, that doesn't go
when
away.
yeah, that doesn't go away. I know that, but when you have like all this, smart science people watching your
Mhm.
stream, it is a little bit intimidating. Are you intimidated sometimes?
Oh, all the time. Until I remember that, like, oh, it's fine. I make mistakes in front of undergraduates, and I don't care. I try and just roll with them and learn from them, and let them correct me, and we'll kind of use it as an experience to all learn some stuff. And so, what's the difference if I make mistakes in front of an 18, 19, 20 year old versus making them in front of you know somebody who's publishing a ton of research and has a PhD? Yeah, there's no real difference. And most of the people that I've come across that are these like really like the really strong, smart PhD type people, they're super interested in what's going on because they think the content is cool. They think the subject matter is interesting. So that's been something to remove that intimidation. But oh, I always still am intimidated and imposter syndrome and all that stuff.
Fascinating. It's something that often comes up in my interviews with artists. So I had to ask because I was curious to see if it affected
Oh yeah,
professors.
I don't think I know a single person that is in academia that doesn't feel that at some point, especially on the younger end of things, kind of the beginning or early middle of career. I think pretty much everybody still feels that, um, at least to some degree.
That is very curious. I actually know of an expert who's researching imposter syndrome, so maybe it's time to get her on the show.
Yeah, that'd be
Uh,
fascinating.
it would be. Uh, so I wanted to find out if when you're teaching mathematics, are you also teaching the history of mathematics?
I'm trying to. I'm trying to more and more. In calculus, there's a really fun story that goes along with it. And the story that most people will hear when they learn calculus is the story of Isaac Newton and Gottfried Leibniz, who invented or discovered calculus around the same time. And so there's this kind of like weird dueling of their two main ideas. They were talking about some real similar things, and people started discovering that they were talking about them in the same way and formalizing some things in the same way. But the history of calculus specifically goes back way farther than that. And so I've been trying to kind of push past just the basic history that most people will see and try and include some of the really ancient ideas, back to Archimedes and things like that that we talk about in calculus, and then just see if we can like find some cool stories, some uh, interesting anecdotes. I don't get really like historical, I guess. I think there's a difference between telling stories and teaching history.
Mhm.
Um, so I don't really get too far into the actual teaching history so much as I do getting into finding interesting anecdotes, finding interesting stories that will hopefully like keep piquing people's curiosity. Or maybe help them relate to a topic or things like that. So I've been trying to include as much of that as I can.
Yeah, I think that's very, very helpful, and also just gives the students who perhaps find something boring all of a sudden. It kind of changes the pace, I would imagine, of when you're teaching.
Well, and it helps that the story of math and calculus and all that is just super interesting. There's a ton of really interesting people. There's a ton of bizarre kind of situations that show up, and so there's a lot of stuff that makes for just straight up good storytelling, let alone helpful for maybe shining some light on a topic or anything like that. But there's just a lot of good storytelling opportunities.
Not to put you on the spot, but can you tell me one?
Sure. So this one isn't so much related to the stuff that I teach, but in algebra, there's a really famous mathematician, Galois, who is the kind of father of Galois theory, which has some really big results. One of them I'll tell you after the story, but he has all this like really really interesting stuff. But he died, I think, at don't fact check me on this. Well, you can. I think he was 22 when he died, and he died in a duel, um, over, I think, oh boy, I'm trying to remember. I think it was like literally over a girl. Um, And so it's like this brilliant mathematician who gets like sucked into this like pretty childish social situation and then like literally dies in a duel, which I don't know. You don't hear about that kind of stuff. Um, but yeah, that one I think is just really bizarre because it kind of catches people off guard. The main result that kind of is attributed to him is you probably know of the quadratic formula, or at least have kind of like PTSD memories of it from high school math.
Sure.
Um, so there's this formula that we can use to solve quadratic equations, and that's like the thing that you just hammer into high school students. And then there ends up being a cubic formula, which is a formula to solve cubic equations. That's things with like x raised to the third power with other stuff going on. So if you see like an exponent of 3 in there, there's a formula that's really, really ugly to solve equations with those. And then there's nothing else to solve general polynomial equations, general equations with like x raised to some exponent bigger than, I think it's bigger than 3 or 4. And Galois is the guy that proved that that there's no general guiding formula that will help us prove something like x raised to the fifth power plus or minus a bunch of other stuff equals whatever. So that's kind of a neat
Huh.
little result.
It is definitely very interesting. And you say it with such enthusiasm, which again, I really, really appreciate that about you. Have you thought about writing a book?
So somebody asked me this if I was going to write a textbook on my Twitch stream, and I kind of laughed and said like every professor that I know is kind of writing a textbook. Like not really to get published or anything like that, but I'm obviously like writing all my course notes and stuff like that. So that's something that I'm working on. I'd like to end up with a kind of 2 semesters of calculus book of some sort, not ever published, just for my students. I figure I've got all these lecture notes for myself that I wrote when I was first starting to teach. I may as well go back and make them student facing instead of instructor facing notes, and just
Yeah,
edit them a little bit.
it's interesting
And
because I was thinking more a Gen Pop book.
oh yeah, no, I've not thought about doing any sort of like pop math book. Probably because there are so many like really good mathematicians doing really good pop math. And I've only been a consumer of that. I've never thought of actually like contributing to that as a writer. Uh, I read a decent amount of that kind of stuff, and I'm trying to. It's hard to find time, but I've never thought of doing that. No.
That's interesting. I've never heard of the term pop math. Is that a really a popular book series, or are there popular authors that we should be reading?
Oh, yeah, there's some really famous mathematicians that are writing really well for the general audience. It's bizarre to me how good people are at taking big math concepts and writing them really accessibly and approachably. Stephen Strogatz is one. I just finished up a while ago. I say just, but it's probably like in March that I finished it. His Infinite Powers book, which is kind of like a kind of the story of calculus, really, which is really fun to read. It's something that I obviously knew a lot about because I teach the subject, but even for somebody who's really knows a lot about it, it was super engaging, and it was pretty clear that it would be something that would be interesting for people that didn't know a lot about math. He's an excellent writer. Uh, Jordan Ellenberg, I think is how you say his last name. He's at the University of Wisconsin. He's got a couple of really good math books about kind of like mathematical thinking and things like that. Eugenia Chang is another one. She's got a couple of just really good, accessible to the general audience, general public, talking about math. They're they're excellent at it. All these kind of SciComm people, and yeah, they set a really good standard, I think, in writing pop math.
I'm gonna look into that because the closest I've gotten was a book on physics. It was called, I think it was called Non-Mathematical Physics. I don't remember who
Okay.
wrote it, but it was actually fascinating because it actually helped me learn the concepts in physics without
Hmm.
needing the math.
Right.
So that was really good. So what would you say to an adult who, let's say, is 40 years old,
Hmm.
who maybe got as far as grade 10 math and they want to start learning math again? What would you recommend?
That's a good question, and I think it depends on the goals of the person. If they want to go through the rest of like kind of the standard high school curriculum and get into some early college math, then that's a little bit less exciting, I think. But there's a ton of resources out there to finish up, pre-calculus and getting into the calculus sequence and all that kind of stuff. But I think the more exciting stuff is to say, like, what kinds of things might you be interested in? And just get some basic understandings of some accessible concepts like or topics like number theory, which is just kind of playing around with properties of numbers, and you don't need a lot of kind of prerequisite knowledge to start doing that. There's cool things like graph theory where you basically play around with pictures of plots almost, and little diagrams, and you can solve really fun, interesting problems. There's a really famous problem called the bridges of Königsbergs or something like that. I don't know how to pronounce the name. I probably should know this. I'm a math professor and I'm failing at all this remembering thing. But it's a really famous graph theory problem that's like super accessible to anybody. Um, there's a lot of fun, like basic probability things that you can do without knowing or needing to know a lot of the like high school algebra and college level algebra and calculus stuff. So honestly, I think I would really sit them down and just start going through some of the little fields of math that are really accessible without those background knowledge things. And there's a ton of them, and they're really fun. There's a lot of cool problems that I might try and introduce to people. Um, One of the problems that's like one of my favorite things, I do this demonstration with middle schoolers, and it blows their minds every time that I do it. I love it. Is it's a coin flipping problem. You probably all know the probability of flipping heads on a coin is 50%, and the probability of flipping tails on a coin is 50%, right?
Mhm.
So then there's like some pretty basic results in probability that is a part of a middle school curriculum that if you flip a coin twice, then you can count up probabilities. And it ends up being like there's this nice independence property, which basically I'll say, like, if I was looking for specifically flipping a coin twice and getting heads, then it's 50% for heads and 50% for heads. And so when you put those together, you get 25%, right? Half of a half is a quarter. And it's this nice multiplication property of probabilities. But there's this really non intuitive thing that says, well, what if instead of just flipping a coin twice and looking for a pattern in this coin flip in two flips, what if we like flipped a coin until we saw a specific pattern and kept track of all the flips, but then like stopped when we saw something like the most current three flips being heads, heads, tails. And we can compare the patterns, and there's not an equal probability of them happening. It's just this like weird, non intuitive thing uh, that's really fun to show. And you can kind of talk about some of the math behind that. That's been one of my favorite things to show middle schoolers. Um, I'd
Yeah,
probably try and find some of those problems.
that sounds really, I mean, I understood that. So, I think an adult that's just starting out could look into stuff like that too.
Yeah, yeah, and those are fun things because you can sit down and just do it. Like, I could sit down with somebody and we can grab a coin and we can literally just try it and observe what happens, and then start asking those like, "Well, wait a second. We're seeing this thing happening that we didn't expect. Why is that happening?" And those, like I said before, those are the fun questions to start asking and answering. Like, why is this the way that it is?
Professor Peter, what does a math teacher do for fun?
We do lots of things. So for me personally, I used to play a lot of video games. I don't have as much time and energy to do that anymore. I don't know. I do the same thing that other people do. I play music. I play guitar, so I do that when I can. Um, I read. I'm really big into fantasy and science fiction. I'm the about what you'd expect from a math nerd, I guess.
I didn't know that about it. I didn't know that you played the guitar.
Yeah,
So,
yeah.
let's touch on that for a minute then. When did you start playing the guitar?
Near the end of high school, I started playing. My dad played guitar all my life, and my older brother had played guitar since he was like 7 years old or something like that. So it had been around. And then I decided I wanted to impress some girls, and so I wanted to learn a couple of songs so I could play them at high school parties. And so I got my dad to teach me a couple of basic songs. Um, and then I went to college, and I had a lot of alone time in between courses and stuff like that when I was hanging out in my dorm, and some of my friends were still in their classes. Before like 5 p.m., I feel like there's a ton of solitary time when you're a college student. And so I just played guitar during those times when all my friends were still in classes. And so that's kind of when I picked it up.
And so, you said that you don't have as much time to play it, unfortunately, right?
No, no, it's the teaching online is a ton of work. It's really time consuming. And then it's just the normal adult stuff. My wife and I had a baby about a month and a half ago. And so there's all of
Aw.
that. And then been doing some work on my house. And so that obviously takes up a bit of time. And then I'm also a student actually right now. I'm working on a master's degree in applied statistics. And so every night pretty much I sit in front of my computer and I try and watch a lecture or work on a homework assignment or do that kind of thing. So I'm kind of filling both roles, professor and student at the same time.
Man, you
I
are
wouldn't say I'm
busy.
doing that one for fun though. That one's just something that I'm doing.
Why are you doing it?
Well, partly for fun, I guess. um, part of I part of the motivation is that when I came out of graduate school, I had a degree in pure math, and I was not from like a top 10 grad school programs, and so I found that even if I didn't want to teach, I wasn't able to be really qualified to get a job in industry like I had originally thought. I didn't have any applied skills. I knew how to think about math stuff, and that was about it. A ton of the people that are getting those jobs know how to do things like computer programming, and they know how to do some other applied skill. And I just didn't have that. So I had the opportunity to take some classes where the institution that I'm at would partially pay for some of those because it's professional development, if it's relevant to what I'm teaching. And so I thought, yeah, this would be a cool thing that I can do. I had some good plans on how I wanted to incorporate the stuff that I was learning into my classes, but I also thought, like, this is a neat applied skill that I'd like to know more about. I'd like to be able to do some more of the applied math things that I didn't know how to do earlier. So that's where I'm
It
at.
it also kind of future proofs your career. I
Yeah, right. If
know.
this goes belly up, I got something to go for.
Well, exactly. I mean, I'm 43. I'm in a career transition
Mhm.
completely. I mean, I'm
Mhm.
going from the software industry to marketing, and it's quite the thing. And there's a certain realization that happens after you've been in the same industry for a while. In my case, 20
Sure.
years, which is that if you don't keep learning, you're out of the job market essentially. So you do have to like all of a sudden start to learn new skills. And so in your case, I think it's wise not just to apply it to your teaching, but you're also future proofing
Yeah, yeah,
for.
absolutely. And part of that was before I got the job that I'm at right now. I was immediately before it, I was having a hard time finding consistent work teaching math, and I knew I didn't want to teach at the high school level because there's so many things that go along with that. I knew I wanted to be at the college level, and I just wasn't finding a lot of job openings. I didn't want to move locations, which is a tricky thing, and so I thought I would start looking for those industry jobs, and I realized very quickly that I wasn't qualified for any of them.
Mhm.
And so even after I got this job that I'm at now, which I love and I don't plan on leaving, I thought it might be nice for me to grab something just in case, because I was faced with the very stark reality that I was not qualified to do anything outside of what I do now.
Right. Let's talk about movies for a second here because there's a
Sure.
lot of movies about math actually.
Yeah.
There's,
Yeah.
Beautiful Mind, there's like The Theory of Everything, I think it's called.
hmm
What are some of your favorite movies that involve mathematics?
Yeah, so this is a really good question, and also one that I am really going to be bad at answering because I know of a ton of movies that involve math, and I have not seen many of them. I haven't seen A Beautiful Mind. I haven't seen what's the Ramanujan movie that came out just a bit ago? The Man Who Knew Infinity, I think it's
Right.
called. I'd love to see that. I read the book and I really liked it, so I'd like to watch that. I really liked the oh, what was it called? It was the one about Alan Turing during the World War II. Um,
The Life of Others?
no,
No.
it's like The
No, that's
Impossible
another
Game or
one.
something like that with Benedict Cumberbatch or something. I forget his name.
Yeah.
Um,
Yeah, I know exactly what film
yeah,
people
the
are gonna be
Alan Turing
yelling at
movie
it.
I really
Yeah,
like. I
yeah.
know they're gonna hate me.
Yeah.
I can't remember a single thing on this podcast episode, but that's okay. I enjoyed that one. I thought that was pretty fun. Um, then other than that, this is gonna sound really, really silly, but there's a Donald Duck movie. It's like Donald Duck's Magic Math Adventure, something like that, and I saw it in high school, as like our teacher showed it almost as a joke because like showing Donald Duck to some high school students, and I actually thought like, well, that does a really cool job of showing some of the neat stuff in math. And I've talked to a couple other math professors, and they have similar experiences where like we don't love saying it out loud too much, but there's this Donald Duck movie that's actually pretty cool, with some math stuff going on in there. That was a neat one. And then Flatland is another cool one. It's about two-dimensional people, and they encounter a kind of a third dimensional, a three-dimensional person, and they have to come to grips with like what that even looks like and what that means. So that was pretty cool.
That's very neat. The Donald Duck one actually makes me laugh. I wonder if maybe you guys could like get a license from Disney or something to actually use it in your classes because I certainly wouldn't you know uh be ashamed to watch a Donald Duck movie
Yeah,
if
it's
it
like
means I'm
a.
going to understand it.
I think it's only like a half hour, and it's. I'm just looking it up now. It's Donald Duck Math Magic Land.
Oh,
It's about a half an hour, from 1959, but it holds up.
huh, very cool. I definitely did not know about that. Do you find yourself sometimes when you're watching television or movies kind of yelling at the TV where like you're like the math is not right?
Only sometimes. It's always impressive when there's something going on and it's like, "Oh, that's real math." I was watching, the Mrs. Maisel on Amazon, and I don't know if you've seen that show. It's about a
Yes,
stand-up
it's
comedian.
fantastic.
Okay, yeah, so her dad is a mathematician, and, in everything that I've seen on there, it's like, "Oh, that's real math," and he's actually teaching that, like, maybe not well, and sometimes when he's, under a lot of stress, but all the stuff on the board and all that kind of stuff, it's real, which is pretty cool. That one always impresses me whenever Abe Weisman has some math on the board.
Yeah, I always, find it fascinating, working in software myself, I always
Mhm.
found that that was not accurate in most of the pop culture references.
Right, yeah.
They're not really hacking, trust me.
Oh, yeah. I always laugh whenever, like, you can tell they're just throwing a lot of jargon around and things like that. Um, but you'd be surprised, but math doesn't show up as, like, a really cool side gig in a lot of TV shows and movies, weirdly enough. I know you'd think it would be the most interesting thing to include off on the sides.
That's interesting, isn't it? Wasn't there have there ever been any superheroes that did math?
Oh, probably. There's what I learned when I started talking about superheroes was some of the, and I mean this in the nicest way. I mean this as a compliment, but some of the real like comic book nerds, is that there's a superhero for pretty much everything. They maybe aren't very popular. They maybe didn't have a long run, but I knew a couple of like people really into that scene, and I would bet that there's a math superhero just because they've pretty much exhausted everything there.
Yeah, I mean, I think, Doctor Strange was a scientist.
Hmm.
I think Jean Grey was a doctor of something, I don't know what,
Yeah, there's
but
it makes sense to me that there's a lot of scientists and stuff like that. There's that curiosity about the world as well as kind of the physical skills to do something and I don't know, create some sort of abomination or whatever. That math doesn't really have that part of it, right?
yeah.
But I would bet that there's a math superhero floating around.
Probably. I'll probably Google it after this episode and there's
Yeah,
like 100,
put
you
it in the
know?
show notes.
Yeah, exactly. So Peter, what's the best way for people to, to find you online or I know your Twitch, we're definitely gonna put the notes in the show notes, we're definitely gonna put a link to your
Yeah,
Twitch
sure.
channel. But you mentioned YouTube earlier. Is that something that you do regularly?
Yeah, I have mostly course content on YouTube, but I have a couple of videos of stuff that I just think is fun, kind of along the lines of um, what I used to do on those Wednesday night fun math things, where we just talk about an interesting topic that try and keep accessible to people that maybe don't have a big math background. But I do have a YouTube channel. Um, I think it's Professor Peter Math or something like that. I don't remember. And then I've got a Twitter account as well. I'm Math Prof Peter on there. I wasn't very smart when I picked my online name because it wasn't available on all the platforms that I use.
That's okay. Even for the podcast, I had to use Planet B612 FM. I couldn't
Oh,
use,
right.
yeah.
Yeah.
So, that happens sometimes, but in the end, I think it doesn't really matter.
No, no. Yeah. So I'm Professor Peter or Math Prof Peter or something, some combination of those words, around on YouTube, Twitter, and Twitch.
Excellent. We'll put all the links in the show notes. Listen, Professor Peter, it's been a real joy. Thank you for kind of inadvertently making me kind of love math in a way. In a way, I'm going
Well,
to
I'm
use that
glad.
a little bit loosely because I'm still kind of a newbie to enjoying math as an adult.
Mhm.
So I really appreciate it, and please keep the enthusiasm.
Oh, yeah. No, I think that's something that, I always try and be mindful of. People are so much more receptive when you have a smile on your face and some enthusiasm, and it's easy for me to do because I like the stuff that I talk about.
Yeah, it is it is pretty easy when you do love what it is that you're talking about.
Yeah.
Absolutely. Thanks for coming on the show.
Oh, thanks so much for having me. This was a ton of fun.
Been a pleasure.